Hello. This video is to show you guys for today's activity, something called the DIY activity. So if you're ever sitting there watching Mr. Edwards go on and on, like, oh man, this is easy. I could do that. We're going to see today, it's not that easy. This problem, you are going to make your own problem. Do it yourself. There's an activity, we've done this in years past, and every year, some of the students give me nonsense. Give me a missile that goes 25,000 miles in the air. No, it didn't. Give me a bug that crawls 0.00001 inches. No, it didn't. So you need to make this make sense. So let me explain how this activity is going to go down. I am going to switch it over to the actual activity, what you guys are going to see itself. There it is. Here's the activity itself. It's called Make It Make Sense. Intercept form. We learned about intercept form on Thursday and Friday. We are making these problems now that make sense. Do it yourself. So here are the directions. Pretty easy. You and a partner are going to make up a word problem on your own. It needs to be something that goes up and then goes down, or goes down and then goes up. How creative are you going to be? You're going to go down on this slideshow, make a new slide, put your names on top of it, write the creative math problem, ask 3 questions about your math problem, and put an answer key in the bottom right-hand corner. The next slide is going to be my example. When I come back, I am going to pick my favorite one, and that's going to be the quiz for everyone in the class. So if it's yours, you already know the solutions. You made it, so I'm hoping you can do it. So let's look at these real quick. This is mine. We'll go through and do mine together in a second, but I just wanted to show you kind of what some of these should look like. Here's one from last time, didn't get a lot done. Bummer. This one's pretty creative. Okay, jumping in the water, coming back up, or okay. Pharmacy prices, that's unique. Thank you. Rita's buying. Rita's is so delicious, by the way. Gelati. Next one, stock market. We've done some stock markets and stuff. I like that. Okay, sledding. This one was super creative. I'm pretty sure they use ChatGPT. Jumping up and down, right? That goes up and then goes down. That makes sense. Some Minecraft stuff. A basketball. A paper airplane. Up, then down. Potato chip flavors. Mayo and mayo. Weird. A bird. This is, I think, is the one that won. It made the most sense. The numbers worked. Simple, concise, neat looking. Excellent job last year, Carissa and Adriana. Now, I want to go back to mine. How to actually solve these. It says the intensity of a siren as an ambulance drives by can be modeled by that equation. I is the intensity of the sound, and D in measured in decibels, and then T is how many seconds since you saw the lights. So as you're driving, you look up, you see the lights first, then when you hear the siren, you pulled over. How many seconds passed from when you saw the lights to when you heard the siren? How many seconds does it take for the ambulance to be closest to you that it ever will be? And then what is the loudest the siren ever was? Okay, so to handle this, I'm not forcing you to do this. I'm just highly suggesting it. Sketch a graph. Sketching a graph on these things, especially intercept form, it's pretty easy to find some of the key features and make a graph. So let's look at this one. Here is the equation. Looks like this. Nice. I'm just shooting from the cuff here, shooting from the hip. Let's do this. So I want to sketch a graph. So the easy thing to find in intercept form are my x-intercepts. One is going to be at +3. One is going to be at +31. Okay, 3, 31. I'm looking at the a value. The a value is negative. So I know this thing's going to open down. That's it. That's the sketch. Pretty darn easy. We have time here in seconds. We have the decibel level, how loud that siren is. The closer it gets to you, the louder it's going to be. And then we got to answer some questions. The first question says, after you hear the siren, how many seconds does it take until you pull over? Well, let's kind of go through this here. Right here, to begin with, is when I actually see the lights go off in my rearview mirror, but I keep driving. I haven't even heard it yet. Then right here is when I hear the noise, so I pull over. It gets loud, and then quieter again. I don't know how good my microphone is. But how many seconds pass until you finally pulled over? The answer is 3. Right when this is right when you heard the noise, so that's right when you pulled over. 3 seconds. Piece of cake. Next one says, how many seconds did it take for you to until it was at its loudest? Okay, well, at its loudest is right here, but I'm asking about seconds. How many seconds does it take to get to its loudest? We're talking about this guy right here. That's the AOS. We find the AOS by adding our two x-intercepts together and dividing by 2. We're finding their average. 31 plus 3 is 30. From when I see the lights in my rear view until it gets super loud, the loudest it's ever going to be, it takes 17 seconds. That's it. The last question was, what is the loudest it will ever be? Well, that's going to be right here. There's its loudest. That's the vertex. We already found H because it's the same as the AOS. I want to find K. What is this value up here? What is the decibel level up here? Well, we know it happens after 17 seconds from the previous one. So all I have to do is take that 17 seconds and plug it in up here. So let's do that. It's going to be negative 0.56. And then I'm going to have 17 minus 3, 14. 17 minus 31, that's negative 14. We talked about that. And then we're just going to multiply those three numbers together. Let's check it out. Negative 0.56 times 14 times negative 14. The loudest it will ever get is 109.76 decibels. Pretty darn loud. Those things are loud for sure. So that's just solving the question. And let's check my answers because sometimes I make mistakes, but hopefully I didn't in this case. Oh, that's me. Hi, me. There it is. 3 seconds, 17, and about 110. Yeah, I said 109.76, but that's what it rounds to. So that's solving the question. 3, you can make any questions you want. Those are just some of the key features. Now, I want to show you something here, a couple things. This is a long video, dang. The next one, ones that don't make sense. I'm not calling this person out, but this was one of the ones from last year. It says a new movie is released and is modeled by the equation. M equals, okay, you guys can read that, where M is money and T is in months. How much is the most money made? Okay, I mean, if I do that one, we're going to get a number, but it's not going to make sense. It's not going to be a very big number. When is the most money made? Okay, I guess that's like the AOS. How much money did they start with? That doesn't even make sense. What do you mean start with? Like the movie doesn't have money itself. This one did not make sense for a bunch of reasons. How about that this thing opens up? I'm looking at the A value. A value is 8. That means it goes down and then goes up. So it's losing money. Something happens and it gains money forever. This one didn't make sense. And really, all of them, to some extent, get goofy. So we had to really focus on why is this not making sense? Well, what about this doesn't make sense? So I'm going to try to help you guys. I'm going to do one right now. I'm going to make one up off the cuff. That's what I meant to say earlier. Straight from the hip, shoot from the hip, and we're just going to make it up. I'm going to show you guys how this works. So let me switch the camera over. Let me grab a marker. We need to think of a situation where something goes down and then goes up, or goes up and then goes down. And I'm going to come up with, let's say this one's going to be time. This one is going to be B for bugs. So we go outside, we notice ants. This happens to me quite a bit in my backyard. I notice some ants. There's a certain number of ants. I'm going to go lay out a bait. When I lay out a bait means more ants are going to show up. More and more ants are going to show up until that bait starts to take hold. And then they're going to start dying. And then slowly but surely there's going to be no ants until finally there are 0 ants. That's cool. I mean, that's a up, that's a down, it's a U shape. That's what I'm getting at. Cool. Now we need to make an equation that kind of mimics this. But we learned about intercept form. An intercept form needs 2 x-intercepts. So I'm going to continue this one just so I can see where that other x-intercept is. Like I don't need it as part of my problem, but I need it as far as my equation's concerned. And then I'm just going to make up some numbers. I like dealing with even numbers. Just it makes life easier sometimes. So I'm going to put this one as -2 minutes, I guess. And then this one I'm going to make 16 minutes. Doesn't really matter, except it's an even number. So now we're starting to construct this thing. If I was going to write the equation, the number of bugs equals some a value. There's always an a value. And then I have x plus 2. T in this case. T plus 2. And then t minus 16. Remember those little sign flips because we're setting those equal to 0. Okay, that's getting pretty close to an equation. I need this to make sense, though. I don't want there to be 12 trillion bugs. Okay, this is just my backyard. It needs to be more than 3 bugs. So I am going to kind of cook this problem I am going to force the a value to be something that makes sense. So to do that, I need to find the AOS, the middle part, right? So I have 16, I have -2. The halfway point between those would be 16 plus -2 divided by 2 is 7. Okay, so if I plug in a 7, I'm going to get to my maximum value. I get to pick what I want my maximum value to be in this case. Let's do a good number, 300. So I'm going to say that if I plug in a 7 for time, t equals 7, then the amount of bugs I want to be 300. And if I plug all those numbers in up here, the only variable left, the only thing to figure out is the a value, and that's what we want to figure out. So let's plug in these numbers. I'm going to say there are 300 bugs. I don't know what the a value is, but if I plug in a 7, I know I get 300. So 7 plus 2, 9. 7 minus 16, -9. 9 times -9 is -81. So I'll have 300 equals a times -81. I'll divide both sides by -81. Oh, look, I already did it up here. And I get -3.7. That is my a value. My a value for my equation, b equals -3.7. And then I have t plus 2. I have t minus 16. And I made an equation that makes sense. Okay, we have typical questions. How many bugs were there to start with? I can do that. What's the most amount of bugs? How long does it take until there's the most amount of bugs? How long does it take until there's no bugs left? There's 0 bugs. How many bugs are there after 5 seconds? Like you have this kind of options here. Key features are the good ones, but you have be creative with this. Most creative one is going to win, and I'm going to put this one on a quiz. So this is how you construct these problems. It needs to make sense. It needs to be relevant-ish. You can't just put blobs of goo and stuff. I mean, ants make sense. We can do that, okay? You and a partner working together. The sub is going to give you a certain amount of time. Follow the instructions. I think the rest of it is up to you. It's a long video. Good job. Hi. No!